Morning students, welcome back microprocessor online class. Today we shall discuss about 16-bit BCD addition. In previous video I just explained only 16-bit addition and subtraction. Now in 16-bit BCD addition I take two 16-bit datas. One is HL, that is HL register, we take 3629, and D register for 4738. These two are 16-bit datas. For adding these two datas and applying and get the BCD addition. Okay, in step 1 we take first two lower order digits for HL register and D register. So 29 is a lower order digit of HL register, that is 29. Then one more data for D register, that is 38 is a lower order digit. So we can add, we get 61. Okay, and it will produce auxiliary carry. What is the auxiliary carry flag is? Its affect auxiliary carry flag equal to 1, because in hexadecimal digits, that is 9 plus 8. What is 9 plus 8? 9, then you can add 8 digits. After 9 you can add 8 digits. That means A, B, C, D, E, F, 10 and 11. So we get the resulting bit of 1, then the carry is 1. So 2 plus 1 is 3, then 3 plus 3 is 6. So we get the answer is 61. Here the auxiliary carry flag is affected. So if the resulting value is greater than 9, that is a lower order digit is greater than 9, so we can add 6 for valid BCD digits. So far you can add 6 in the lower order digits. This will done by DAA, decimal adjacent accumulator. If the resulting bit is greater than 9, you can add 6 for each digit. So in the previous video, that is 8-bit BCD addition, for adding DAA, that is the invalid BCD numbers or valid BCD, to convert valid BCD numbers by using DAA, decimal adjacent accumulator. For adding a 6, it's automatically change valid BCD numbers. So we can add 6 for the least significant bit. So 61, before in the resulting bit is 61 plus 06. So we get the result is 67. This is the valid BCD. After that, the step 2. Here in the higher order digits, that is 36 and 47. So we can add 36 plus next partial sum, that is 36 plus 47. Then in the previous carry equal to 0. So what is the answer? The answer is 7D. How it is? That is 36 plus 47, 6 plus 7, so 6, then 7, that is 13. So 13 is denoted as in hexadecimal, it is D. So 3 plus 4 is 7, so 7D. Here the resulting bit, the only bit is greater than 9, that is D. And 7 is less than 9, so you can add 6 for D, that is by applying DAA. So 7D plus 06, we get the result 83. Okay, now the final result will be stored on some memory location. So result equal to 83, then another partial sum is 67. So this is the valid BCD numbers for 3629 and 4738. And now we go to see how it's working 8085 simulator. So this is 8085 simulator. First you can load two datas, that is that's why I am taking two LXI register, that is two pair register LXI for load pair register. H means HL register to load on 16-bit data, that is 3629. One more data for load by using, let's say, D for D register. Here one second data is, that is N2, number 1 and number 2. First number is 3629, number 2 is 47 and 38. Now it will move the content of two lower digits, that is move A comma L. So it will get two digits of number 1. So 29 will be get to move the accumulator. The next instruction, add E. Add E for the content of accumulator. So before the content of accumulator is 29 plus E means the D register is, that is E register is 38. Two lower digits is 38. So 29 plus 38 will be stored again in accumulator. This is the meaning of add E. Then by applying DAA for decimal adjusted accumulator. Suppose if the result is greater than 9, you can apply to adjust to valid BCD. Okay, by use of DAA. Then the first partial sum will be stored on some memory location. So now I'm taking the memory location store accumulator. The content of accumulator stored in C060. Next, then again move A comma H for higher order two digits, that is 36 will be moved on accumulator. Before 29 will be moved on accumulator, then add 38. So the result will be stored on C060. After that 36 will be moved on accumulator. The next add carry. So add with the carry. So D register. So add with the carry means the before previous carry plus accumulator, then D register. So it can add three contents. Okay. After that the result will be stored in accumulator. The resulting bit is greater than 9, so you can add by applying DAA to adjust valid BCD. Okay. Then it will store memory location, that is the next nearest memory location C061. Suppose if you get any carry, so it will move, that is move immediate A comma 00. The accumulator is free from it. After that the carry with immediate will be stored for some memory location, that is STA C062. Then it will stop the program. Okay, so this is very simple one for load two datas for pair register, HL register, DE register, H for 36, L for 29, D for 47, E for 38. So first it move the content of L to accumulator. After that it will add E register. So 29 plus 38 will be added an accumulator. If the result is greater than 9, you can apply DAA for valid BCD to adjust valid BCD. Similarly for these three lines, for moving higher order digits for N1, then add N2. Again the result is stored in accumulator. Suppose if the result is greater than 9, so it will apply DAA. So likewise you can add the next partial sum is some memory location, that is next nearest memory location of C061. Suppose we get any carry, the carry bit will be stored on C062. So now directly go to assemble it. So here the mnemonics will be created, then hexa code is there, bytes code, machine cycle and t states are directly created to 16-bit BCD addition. Now I will run step by step. First it forwarded load two datas for HL register 36 and 29. Again it load D register for 47 and 38. Then the content of lower digits, two digits will be moved on accumulator. Then add two datas. After we'll get to add two datas, that the result will be stored in accumulator, that is 61. Okay, next the data will be stored in C060. Here you see that C060 for the partial sum will be moved on memory location. The next higher order two digits will be moved on accumulator, so 36 is moved on accumulator. After that add D register, so we get the result in 7D. Here the 7D is greater than 9, so D is greater than 9. By adding 6 we get 83. Okay, so 83, the 83 will be moved on C061. So here you see that C061. If it is any carry, here there is no any carry, so so leave it. Suppose where carry is there, so it will be stored in next memory location. Okay, or directly put run all time, you get the result 83 and 61. Okay, so this is 16-bit BCD addition. So here some more exercises there for your practice section. To perform to perform BCD addition, perform 16-bit BCD addition. 16-bit BCD addition. So there are three data are there. First we take 5785 plus 7897. Now you find what is the sum of these two numbers. What is the sum of these two numbers? The next, second one, 9128 plus 3784. This is one more data we get. What is the sum of these two? And third one, 9459 plus 9534. What is the sum of these two? So after watching this video, you can try this. What is the sum of these numbers? Okay, so keep on watching and try the examples. Okay, thank you.